Okay, I'm going to go over this review worksheet. That way you can kind of know what you're going to be looking for. And again, remember, I'm just going to kind of show you some of the numbers, but you're going to have to justify some of the reasons for your answers and what that means. But the main things that are going to be on the quiz is going to be these four standards. I can determine the probability of an event. And the biggest thing there is what is the possible outcomes divided by the total outcomes. I can create or analyze a data display for a categorical data set. I can calculate relative frequencies, joint frequencies, marginal frequencies, or conditional probabilities for a category data set. And I can calculate the probability of a range of values of an independent variable given a mean, standard deviation, and normal distribution. So there was a mistake on this. It says a school newspaper sampled 150 randomly selected students and asked each student which of the following activities they did first after getting home from school: watch TV, movies, videos, or start homework. Students were classified as being in either lower high school, 9th or 10th grade, or upper high school. Following table displays the results of the survey. So I should have, there should have been 200. Because that's the total here. But most of you caught it, or you didn't really read the instructions on that part anyway, so we'll go with it. So what is the probability of a student started homework as soon as they get home? So what you're going to want to look at is how many possible students started homework. So you're going to look at this column right here, and the total that started homework was 80 out of total possible 200. Now, again, we don't really want to keep this. I want to simplify as much as possible. If you have a calculator, that's really easy to do. Alpha y equals enter, or you can just kind of simplify. 4 goes into both 8 and 20 2 out of 5 times, or it'd be good practice 0.40. Okay, that's probability. Now we don't want to do a percentage. This just means 2 out of 5 students started homework, 4 out of 10. Different probability, that's what we're looking for. Okay? So what is more likely? A lower high school student watching TV after they get home, or an upper high school student starting homework? So you're going to have to find two different probabilities. So let's look at a lower high school student watching TV. So if I go to lower high school watches TV, I have 54 possible out of the total 200. So again, it becomes real easy if I have a calculator. Alpha y equals enter 54 over 200. I get 27 over 100, or 0.27. Okay. Upper high school student starting homework. That's 44 over 200. Possible outcomes over total outcomes. So again, alpha y equals enter 44 over 200 gives me 11 over 50, or when I divide that, 0.22. So now that I have the numbers, which is more likely to happen? Well, you're going to look for the bigger number. There's a bigger chance of a lower high school student watching TV because the probability is 0.27 compared to an upper high school student starting homework, because that probability is 0.22. So again, it's more likely a lower high school student watches TV. And you'll just need to communicate that in words. Okay, this one. What is the probability of being in lower high school given that the student starts homework. Now, the key word here is given. Okay, the given changes things. It changes the subset. So we're not looking at the total. We're looking at how many students started their homework. That's going to be our total, our bottom number. So what I was seeing a lot the other day was you saw lower high school, and so you would put 90. But we're wanting to look at how many students started their homework. So that's going to be the bottom number, 80. And how many of those lower high school students started their homework? 36. Okay. So 36, when I simplified, is 9 over 20, or 0.45. So the possibility of it being a lower high school student starting their homework is 0.45. That's what that means. So that given changes that bottom number because we're looking at a subset of the total. Now, this one was really interesting. Is the following independent? Well, if you look at your homework or your notes, it says to be independent, you have to do the probability of A times the probability of B, and for it to equal the probability of A and B. Okay. So what does that mean? Well, is the following independent, being in lower high school and starting homework? So my A event is going to be being in lower high school. My B event is starting homework. And then this last part is lower high school and starting homework. So let's look at being in lower high school. So I'm going to look at the total. 90 people are in lower high school over the total 200 times starting homework. Well, I had 80 people start homework out of 200 total equals the probability of lower high school and starting homework. So I'm going to look in that box, lower high school and starting homework is 36. Now, most of you got to this point and said there's no way that that equals one another. And so you just said dependent or not independent. But let's follow through on this. So I'm going to change these over to decimals. I'm not going to worry about simplifying it. So 90 over 200 is 0.45. 80 over 200 is 0.40. And 36 over 200 is 0.18. So again, you look at this and say there's no way that 0.45 times 0.40 equals 0.18. Well, let's see. All right. So 0.45 times 0.40 equals 0.18. So do they equal one another? Yes. So it is independent. Because the probability of A times the probability of B equals the probability of A and B. So you have to finish this out. It can't be what you think it's going to be. There's no way that 90 times 80 equals 36. But it is. Okay. All right. So those were pulling out data. We found probability. We analyzed data from a categorical data set, and we looked at relative frequencies, conditional. We looked at a lot of different things. Okay. Now, this right here. An airline has a flight scheduled for 9 a.m. every morning. The flight departs early on some mornings and late on others. The airline has analyzed past departure data and determined that the distribution of departure times in minutes after 9 a.m. is approximately normally distributed with a mean of 7 minutes and a standard deviation of 4 minutes. Now, what I saw a lot of people put 7 immediately into here: 11, 15, 19, 4, -1, -5. However, if you read closely, it says the distribution of departure times in minutes after 9 is approximately with a mean of 7 minutes. That means the average departure time is 9:07. 9:11. And you're going to go up by 4 minutes or down by 4 minutes. 9:03, 8:59, 8:55. Okay? So be sure you're looking at that closely. Now, these numbers are always the same. We're talking about probability here, not percentages, probability. So these numbers are going to be the same. 0.34, 0.34, 0.135, 0.135, 0.0235, 0.0235, and the outer one's 0.0015. You have to memorize these numbers. It's essential that you do that. Now, it makes everything else easy now. What is the probability that on a randomly selected day the flight will depart after 9:11? So I'm just going to cover that up. 0.135 plus 0.0235 plus 0.0015. When I add those together, I get 0.16 probability the flight will depart after, let me write everything down, after 9/11. Okay. AM. So there's a 0.16 probability the flight will depart after 1:11. What is the probability that on a randomly selected day the flight will depart between 8:59 and 9:11? So now I'm going to add up 0.135, 0.34, and 0.34. So when you add those up, you get 0.815. And again, 0.815 probability the flight will depart between 8:59 and 9:11 a.m. And so if a random sample of 40 days is selected, how many flights would you expect to depart between 8:59 and 9:11? We know the probability is 0.815. And up here it states an airline has a flight. So one flight per day every morning. So I'm just going to take 40 because there's 40 flights in 40 days times 0.815. And when you do that, you get 32.6. Now, that is not the answer I'm looking for. Okay? And a lot of you might say, well, you can round. Well, what if it's 32.4? If 0.4 of a flight takes off, is it still taking off? Okay? You can't have anything above 0. Like if you take one little bite of a candy bar, have you ate the candy bar? Yes. So I would say there's a chance of 33 flights between those two times. 859, and 911. Okay, so again, you need to understand how to find probability, and you need to have these memorized. If you know those things along with this independence, you should be fine. But you need to be sure and study this and be ready for the exam.